Guys, in this video we're going to be talking about the ellipse. This is the second conic section that we have gone over. We did the parabola in the last video. We're doing the ellipse now. And notice I'm not saying eclipse. A lot of people want to call it the eclipse, like total eclipse of the heart. I'm not going to play that. If you want to stop and listen to that song, you can. But I'm saying ellipse. And this is formed from the double helix conics that we've already talked about. And the idea is that the plane, the sheet of paper, whatever it is, it's going through one of the cones at an angle. And whenever it does that, it forms this oval. I'm not going to call it an oval, I'm going to call it an ellipse, kind of like an elliptical. If you're on an elliptical, this is the motion that your foot makes, kind of like a circle, but stretched out a little bit. Or you think about the planets, they're in orbit and they're in an elliptical orbit around the sun. They don't go in a perfect circle around the sun, so it makes it so we have seasons and so forth. Well, you might be looking at this and say, well, that kind of looks like a circle. And a circle is going to be just a special case of these ellipses. If the plane was to go horizontally through it and cut it perpendicular with, I guess, the base, then yeah, it would form a circle right there. And so the circle is just going to be a special case of the ellipse. I don't know if we're going to see any of those in this video or not, any circles, but we definitely will see ellipses, and if I think about it, I'll let you know how a circle would come out on this. I'm interested in important info on this. When I say list the important info, first up, I'm going to be wanting the center. I'm going to be wanting the very center of the ellipse. Right? So that's where everything's based off of, is where the center is. Hopefully the center will be at 0, 0, and it will be some. Sometimes it won't be. Okay. Next, I like the vertex on each end. So plural for that will be vertices. I'll be interested in where these vertices land. And notice vertices are further away from the center than the co-vertices are. Okay. A lot of books don't really deal with the co-vertices, but I'm going to go ahead and include them this year. I think it's important to list them and know where they are. Okay. And finally, we have the focus on either side. You ready for this? The plural of focus is going to be foci. F-O-C-I. Some people call it foci. I think it's one of those tomato things. So either way you want to call it. And so we'll have those listed as well. So I said it doesn't look like we were going to list very much, but we are listing quite a bit on this. And so we'll talk about where to get all that in just a minute. A couple of other items that are on this that I did not mention was the major axis. I will be talking about the major axis, but the major axis is not anything you have to label. The major axis is going to be the longer line of symmetry that is connecting the vertices, whereas the minor axis is going to be the smaller line of symmetry that connects the co-vertices. Notice I didn't say the major axis is the horizontal line of symmetry, because it's not always going to be a horizontal ellipse like we have here. Just like the parabola can face up, down, left, right, the ellipse can be oriented horizontally or vertically. Now, this is a lot of information up here. Please don't think we're going to cover all of it, because we're not. Okay, so I'm going to box in some stuff that I think is important. First off is this general form right here. Okay, here's my general form. The general form is going to be two rational expressions that are being added together, and then there's going to be an equals 1 on the right side. Now, on top of that, there's this extra little bonus equation down here that's going to relate some of the important parts of my ellipse. Okay, so my center is still going to be at HK, right? So I've still got it rocking right here at HK, and that's the same HK that we dealt with whenever we did the parabola. So that's not going to be much different, except for this time it's called the center, not the vertex. Okay, what's new on this is going to be these distances right here. Like this distance A is going to be the distance from the center out to the vertex. Okay? Whereas B is going to be the distance from the center to the co-vertex. Now, that is the same A and B that you see up here in the general formula. C is going to be this distance from the focus to the center, or center to focus. Not really directional this time because I have two of them. So one's going to be plus, one's going to be minus. And so since there's not a C up here in my general form, what I have is this extra little formula down here that relates A, B, and C. And so it's going to be A squared minus B squared equals C squared. Kind of Pythagorean. If I was to add B squared to both sides, it would be Pythagorean, which makes sense because I can form a nice little right triangle right there, even though we don't have to. All right. Notice I didn't really mess with all this right here in the middle. Okay, I talked about the center, I guess, a little bit, but the foci, vertices, covertices, there are equations that will just spit those out if you want to use them. I think it's easier to get all that information from the drawing down here at the bottom. Okay. Well, what if it's oriented the other way? Well, I still think that this is good information right here. If I have a vertical ellipse, notice what changed from the vertical ellipse to the horizontal ellipse. My A squared and my B squared, they flip-flop. But I still have the same equation that links A, B, and C together. Now, why did A and B flip-flop? It's because down here, this time, A is going to be this vertical distance, because since my ellipse is standing up this time, it's oriented more in a vertical direction, my A is going to be the distance from the center to the vertex. Okay, same as it was over here on my horizontal. And then B is going to be this distance from still the distance from the center to the co-vertex, where C is my distance from the center to the focus. So nothing changed with that. So how do I know which way it's going to work? Let's come back over here to the horizontal. As you can see on the horizontal, that the A right here has to be, since it lies on the major axis, has to be longer than what this B is. So in this case, A is going to be bigger than B. Let's come back over here to vertical, where A is this long distance that's on the major axis again, that's running vertical, while B is having to take on this shorter distance that's running to the co-vertex. So in both cases, whether you're dealing with a horizontal ellipse or a vertical ellipse, your A has to be longer than your B. Okay? A is longer than B. And again, I didn't use much of this information in here in the middle. If you want to try to make sense of it, those are just nice little formulas that will spit out everything you need to know. I think it's easier, though, if we draw everything out. So let's try this. There are several examples today, and have you do maybe a couple on your own. So I'm wanting the standard form. Okay, now I can already tell you a lot about the standard form. I can tell you I'm going to have a binomial squared right here, where this is going to be x, and it's going to be over something. And then I'm going to have a binomial squared, where this is going to be y. I don't know if it's a minus or not. It could be a plus. And it's going to be over something. And all that's going to equal 1. So let's draw what we have so far. I know that the vertices are going to be 0 and plus or minus 4. So 1, 2, 3, 4 right here. And 1, 2, 3, 4 right here. So that means my parabola, I don't want to draw the whole thing because I don't want you to get try to get any more information than what we have on this. But since this is the vertices will always correspond to whatever your A value is, where A is going to be the distance from the center, which I think we can go ahead and just assume that 0, 0 is going to be the center, because it's halfway between my vertices. So I can go ahead and plug those in. But my A value is going to be the distance from the center up to the vertex. This is center to vertex, not vertex to vertex. So A is going to be equal to 4. Well, the question is, does it go on the left, where if I had a horizontal ellipse, or is my ellipse vertical and I put the A on the right? Remember, A always has to be bigger than B, but I don't even know what B is, okay? Because remember, foci, this square root of 15 right here is going to have to do with my C. So I don't even know what B is on this, so how do I figure this out? Well, I could definitely plug it into my equation, but I've got an even easier way. If my ellipse is vertical, or if my A is going up in the y direction, then this 4 is going to go underneath the y. And notice it's a 4 squared in my formula. So in this case, it's going to go underneath the y. Now, my foci is at the square root of 15. I don't know what the square root of 15 is, but I know the square root of 16 is 4. So the square root of 15 is going to be just a little bit less than 4. So my foci, if I go a little bit less than 4, it's going to be right, they're going to be right here, just right by those vertices. And I have that handy equation that's going to help me figure out the last variable that I need, because I've almost got my formula. All I need is my b squared right here. So I have c squared equals a squared minus b squared. Well, if c is equal to the square root of 15, then c squared would have to just be 15. I'll work that out in a minute. My a is 4, so my a squared would have to be 16. So that gives me 15 equals 16 minus b squared. I'll subtract 16 from both sides. I get negative 1 equals negative b squared. So my b squared is equal to 1. Be 1 right there. Got all my information. I can clean this up some. I would probably accept this exactly how you see it. If you want to clean it up some, I'm going to go ahead and call x minus 0. I'm going to call that x. You can put it over 1 to show the math teacher that you did actually do the work to find out what b is. But yeah, this would be full credit right here. Notice I didn't come over here and check anything on your graph. All right, I didn't even draw a full ellipse over here. No need to. I'm going to be interested in you coming up with this 1 and the 16 and you putting it underneath the appropriate variable, either x or y. Okay. A lot of stuff going on there. I want you to try one because my next couple examples are going to be a little bit more difficult than example 2 right here. So I want you to try this one on your own. Draw everything out. Use this last one as a blueprint as to where you think stuff should go. And we'll hit pause on the video and we'll come back and see if we can match up answers. Here is what I came up with. If you want to take it further and knock out the zeros, that's fine. But that'd be it. Notice this time my a went under the x because whenever I plotted this, it was going in the x direction. Let's get some that are off of the center. Let's see if that's going to make life any harder for us. Okay. I'm wanting standard form. I like to go ahead and just write out as much as I can of standard form, so I just have kind of like a fill in the blank thing happening here. So I just need my a, b, h, and k. Standard form that has vertices at negative 2, negative 8, negative 2, 1, 2, 3, 4, 5, 6, 7, 8, way down here, and negative 2, positive 2. Let's think about just what we can just get from this information right here. I can get my center. My center is going to be halfway between these two dots. So you can just move your fingers in, or you can definitely do negative 8 plus 2 is negative 6. Half of that's negative 3. Either way, you should land right here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, I'm good. So my center is going to be at negative 2, negative 3. Be careful on this. I want opposite signs on this. Because it's actually x minus h squared and y minus e squared. So I've got to do the opposite on there. I already have that much information. And I can go ahead and get my my A value, because remember, A is the distance from the center to the vertex. So that would be 1, 2, 3, 4, 5. And since I'm going back, I'm crawling up in the y direction, my A is going vertical up and down. This 5 squared is going to go right here underneath my y. So again, it's a lot like the one that we worked together, but the only thing we have to find now is this B. And unfortunately, none of these are going to be my C values, but my foci is, what color have I not used? Let's use black. -2, -7, they're still going to be kind of butted up next to these. And so this distance here is going to be my C, which should be 4. 1, 2, 3, 4. And so I have to make use of this little equation here. So C is 4, so square it would be 16. A is 5, square it, that'd be 25. Okay, if I subtract 25 from both sides, you can see the math is very similar on all these. My B squared equals 9. B would be 3, and we're going to use that in a minute when we have to graph this, but I just want to know what B squared is going to be, so it's going to be 9 right there. This is fine. If you wanted to change this to 25 real quick, that would be great as well. So this would be full credit. I think you guys are getting it. For time's sake, I think I'm gonna skip this example. I might come back to it later, but if you want to work this example and have it ready during the Q&A, that would be fine. They got that square root of 3 in there, but don't let that throw you off. All right, I still think you'll be able to graph it and make it look good. Okay, so if you want to work that one during the Q&A, have it ready, or if you have one that's similar to it in the homework, we can look at it as well. Okay, I want to get to some graphing. Okay? And again, anytime that you graph, because of the nature of a lot of the way that these graphs look, a lot of stuff will tend to get jumbled together, or it starts looking sloppy if you're not don't have the neatest handwriting, or if you're like me and you can't draw that well. So I will want everything labeled out to the side. Okay. So looking at this, I know that my center has to be at 0, 0, because I've got x minus 0 squared and y minus 0 squared. So I can go ahead and label this. Center has to be at 0, 0. Right. Okay. Now, from here, I just kind of work it a little bit easier. I remember that A has to be bigger than B, so this guy's probably going to be A, and over here, the 9 is going to be my B squared. Remember, it's squared. But again, I just like to use my shortcut and just say, well, this A squared, so A is equal to 5, it's underneath my Y value. So from my center, I just need to go up 1, 2, 3, 4, 5, up the Y-axis, and down 1, 2, 3, 4, 5, down the Y-axis. Okay? And then this B came out from underneath the X. And so on the X-axis, since B is equal to 3, I'm going to go 3 on the X-axis, both positive and negative from the center. We almost have everything. I just want to connect these outer dots, do my best not to make a diamond. Good luck. Oh man, that's one of the better ones I've done, so I appreciate that. And I just need to list and label everything. Okay, my vertices are going to be these blue dots right here. They happened at 0, 4, and 0, -4. I'll just call it plus or minus 4. My co-vertices, I have to put COVID, is going to be plus or minus 3 and 0. Oh, thought you were going to get away with it, huh? I haven't labeled my foci yet. Okay. So, again, I'm going to have to make use of that little extra equation I had. But the good news is it's more explicit this time. I can just plug in my 25 and my 9, and I get my C squared is equal to 16. I do want to break it down to c equals plus or minus 4. And remember that the foci has to run on the major axis. The foci should be inside the ellipse every time. So if my vertices ran vertical, my foci are going to run vertical as well. 1, 2, 3, 4. They would land here. So I want to see these dots on here. You can come over and tell me that those dots landed at 0, plus or minus 4. Notice if I would have went the other way, my foci would have landed out here. That's not good. Your foci should always be inside your ellipse. Okay? This is full credit. I want to see all these dots. I want to see all this information. And yeah, it'll be good. Okay, we haven't talked about this yet. Let's look at one that's not in standard form. Let's talk about getting it into standard form. Okay. Remember, standard form is going to be where I have two rational expressions added together, and the big kicker, I have one on the right side of the equation. That's what I want to do on this one. I want to make it so I have a 1 right here on the right side of the equation. Now, don't be like that rare student that says, well, I'll just subtract 99 from both sides. Yeah, that gets 1 over here, but then you have a negative 99 floating on the left side. Instead, what I'd like to see you do is divide everything by 100. Then yes, that gives you 1 on the right side. And if I have 4 divided by 100, well, 4 divided by 100 would be 1 over 25 if I reduce it. So that just gives me x squared over 25. Where'd the 1 go? Well, it's right there. It's just not part of my standard form. Bring down the plus sign. Here I have 25 over 100. Well, 25 over 100 would be the same as 1/4, which would be the same as just y squared over 4. Now I have a problem that's like the last one. So I'm going to, if you'll excuse me, I'm going to go a little bit faster through this one. Remember, my A is always bigger than my B in this case. Or you can just look at it and say, well, the A came out from underneath the X. So I'm going to go 1, 2, 3, 4, 5 in the X direction. Both ways. I'm going to go 2. B is actually equal to the square root of 4. I'm going to go 2 in the Y direction, up and down. You've already got this much of your graph drawn. The only thing I need now are my foci. Sorry. So my foci is simply going to be equal to my A squared minus my B squared. In this case, you unfortunately get the square root of 21. That doesn't help me a lot. So as far as graphing goes, so I'm going to actually take the square root at 21. We'll call it 4.6. And again, I want to make sure they're inside the ellipse. And so they're going to go in the same direction that my vertices go. So 1, 2, 3, 4.6. Oh yeah, we're going to get really tight in here. That's okay, because I'll be able to see if it's in the right position when you list all your information out. Center is at 0, 0. The vertices, they landed at 1, 2, 3, 4, 5, 0, and negative 5, 0. The co-vertices, they landed at 0, 2, and 0, negative 2. What's left? Foci. They landed at, you can just call it 4.6, or you can call it square root of 21. I'll call it square root of 21. I think that's how the book's going to be. Okay. There we go. I want to see that information. I want to see the graph. Good. All right, I'm going to cut you loose on this, and I might help you get started on it, but I think you can get it from here. Okay, so as you can see, the biggest difference on this one is that we have an H and K this time. So the center you're going to have to work off the point 4, 2 right here. 1, 2, 3, 4, 1, 2. Other than that, everything's going to be very similar. So I'm going to let you work through this. We've already done the center. Find the vertices, co-vertices, and foci. Get them labeled, and then get them drawn out, and then see if you get the same thing I get down here. Okay, so go ahead and hit pause on the video. Did I throw you off with that co-vertex? Might have. It turned out that my co-vertex was going to have to be 4.5 units away from the center. So no big deal. We'll just count to 4.5. Close enough's good enough on the graph, and then I can come over here and make sure that you have it in the right spot. That was kind of difficult. Not as difficult as we can get. We get a little bit harder, I think. Look at this one. Why is this one going to be harder? Several reasons I'm looking at. Let me go full screen. Let's do that a little bit. I'm looking at it. There's several reasons it's going to be harder. Yeah, there's no parentheses, no binomial squared. It's set equal to 0. Yeah, it's not good. It's not good at all. So I've got to force this thing into standard form. Okay. So I definitely saw this as an ellipse or a hyperbola last year in the final, where they had to do all this work to put it in standard form. So pay attention to this. Work this one out in the practice problems I'm about to give you. Okay, so first order of business I'm going to do is I'm going to get all of my x's together, and I'm going to get all of my y's together. And if it does not have an x or a y, I'm going to boot it off to the other side. So I've subtracted 100 from both sides just in rearranging. Okay. Now, I'm thinking about my standard form with this. Remember, my standard form is going to be, I don't know if it's going to be a squared or b squared. I'll just put an a down here. I'll switch it in a minute if I need to. Over b squared is equal to 1. Okay, so don't add 99 to both sides, or add, I guess it'd be 101 to both sides. Don't do that. But we've got to get some binomial squareds up here on the top. And so to do that, I need it so that the variable that's in front of my x squared is a 1. So I'm going to look at my x's right here, and I'm going to pull a 4 out of them. I'm pulling out whatever will make it so this x squared has a coefficient of 1. Okay. I'm going to do the same thing with my y's. I'm going to pull the 9 out. A lot of times it's going to, I guess every time it would be the greatest common factor. That negative 100 is scaring me. I mean, we might have to change that in a minute. Hopefully not, but it's scaring me right now. Now, I left some very convenient spaces right there. A lot of you already know what we're going to do in those spaces. Some of you don't, but a lot of you do. Yeah, I'm going to complete the square in these spaces. I took half of this 10. I'm running out of room. I took half of the 10 and squared it. So it's 5. 5 squared is 25. Okay. I'm going to take half of this 4 right here is 2. And I'm going to square it. And again, I'm going to jump ahead a little bit. The reason I did that was I'm making it so this will both of these parentheses will factor nicely into my binomial squareds that I wanted, that I have up here at the top. So I'm good. Now I've got some other stuff happening. Okay. For instance, I added 25 right here. I can't just randomly go around adding 25 to one side of the equation and expect it to still equal negative 100. So I didn't actually add 25. I actually added, 4 times 25, 100. So if I add 100 to the left side of the equation, I need to add 100 to the right side of the equation as well. Same goes for this 36. I didn't actually add 4. I added 9 times 4. Now I don't feel too bad about that negative 100 because it'll actually cancel. And so what's going to happen is this 4 is going to come down for the right. This 9 is still hanging out in front. And the only thing that I have on this right side is the 36. Now this looks very similar to example 6 that we worked together. Remember, I want to have a 1 on this right side. So if I go through and divide, I didn't mean to do that. If I go through and divide everything by 36. Again, some people get confused on this. This is actually 4 divided by 36. A lot of people say, well, it's 9. Well, it's actually 1/9. You can do a reverse division on it. I saw this on a video. It's kind of cool. They said 36 divided by 4. I did a reverse division, and I just put it on the bottom. It's going to be a 9. So either way, it's going to be 1/9 or just a 9 on the bottom. And that's going to leave me with this x minus 5 squared on top. Same thing here. 9 divided by 36 is going to be 1/4. So the 4 goes on the bottom. You can do 36 divided by 9, and then put the 4 on the bottom. Reverse division. I don't even know if that's a thing. I might have just made something up. Finally, standard form. That was a booger. All right. I think you guys can get it from here. I'm going to find my center is going to be at 5, -2. I hope I obeyed all the signs on this video. In the x direction, I'm going to go square root of 9 units, so 1, 2, 3, 1, 2, 3. And then in the y direction, I'm going to go the square root of 4 units. So, I use the same color. That'll be all right. 1, 2, 1, 2. So I've almost got my whole thing here. I have a lot of people that make it to here, and they get a lot of credit on it. But I do want to see your foci in order to get the full credit. So c squared is going to equal 9 minus 4. Don't leave it as 5. That's going to put it outside the ellipse. C is going to equal the square root of 5, which comes out to be, like, is that 2.2? Second square root of 5, 2.2, yeah. And that goes in the direction of the vertices. So 1, 2.2. If I went the other way, it'd be outside. Full points on the graph. List everything out for me. So I have center at 5, -2. Vertices, count nice. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, -2. And 2, -2. I don't get to use my little plus or minus trick on there. No vertices. 1, 2, 3, 4, 5, 0. And 5, 1, 2, 3, -4. And then foci, either one. It's going to be kind of weird. Land at a weird spot. 2.2. All right, so that means that this has to be 1, 2.8, -2, and 1, 2, 3, 1, 2, 3, 4, 5, 6, 7.2, -2. Lots going on there, but I think we worked up to be able to work this problem. Okay, so we see it. I don't want us to shy away from it. We've got to be able to do it. Okay. Here's the problems. I'm going to model the quiz after. And if you have any questions, put a big star by them. We'll definitely talk about them next time we see each other.